Hello, welcome back. Now, let's understand how the exception level 2 can be used in the system. So here is the architecture diagram where there is only one, the single operating system. So in this case, we don't have to use the exception level 2 because exception level 2 was introduced to support the virtualization feature. Virtualization means that there are more than two operating systems in non-secure world. Then there should be the hypervisor that could be running at exception level 2. Now let's look at another architecture diagram that show you the virtualization system. The key difference from this architecture diagram is that there are more than two operating systems. In the virtualization system, the operating system can be called guest OS. In this architecture diagram, there are two guest OS here. This is the guest OS 1. Here, what you can see is guest OS 2. So the role of hypervisor is to manage the hardware resources that is used for each the guest OS. For this reason, the hypervisor should be running at exception level 2, where exception level 2 has a higher privilege level than exception level 1. The biggest reason is that the hypervisor should check or monitor the workload of each the guest OS. So based on this information, hypervisor can manage the hardware resource that could be allocated to the various guest OS. Take for example, if the guest OS 1 is very busy with a higher workload, hypervisor should allocate the more virtual CPU, the more the virtual memory area to the guest OS 1. But at the same time, the guest OS 2 cannot be busy in some cases. In this case, hypervisor doesn't have to allocate the virtual CPU to the guest OS 2. For this reason, the hypervisor should monitor the workload of each guest OS. For this reason, the access to the system register surfaced with EL1 should be allowed at exception level 2. Now, so let's take for example of the system register that is accessible at exception level 1. So here is the part of the starter code that can be used during the boot up starter code in this corner. Here, the three are the system register that is surfaced with exception level 1. So this system register is TTBR 0 EL1 register. Here, TTBR 1 EL1 register. As for this system register, it is called system control register surfaced with EL1. But remember that hypervisor can access those kind of system register to monitor the workload of each the guest OS to identify some of the configuration that is already done at exception level 1. As you know, exception level 0 it talks to exception level 1 very often using SVC assembly instruction. So using the assembly instruction, SVC assembly instruction, system call can be invoked. Just like SVC assembly instruction, HVC assembly instruction can be performed at exception level 1 to talk to exception level 2. So this kind of operation by running HVC assembly instruction is called guest exit. Here, the ARM architecture support another assembly instruction to transit from EL1, EL2. That is WFE and WFI assembly instruction. So when running this assembly instruction, the control is transferred to exception level 2 by generating exception. So this is a standard way to communicate between exception level 1 and exception level 2. So as a third step, so per encounter, we jump to the exception vector address that is specified here. The value of v bar EL2 can be added to offset 0x400. So here, this is the typical way for the hypervisor can communicate with multiple guest OS. Now let's summarize the important point that is about exception level 2. Just like exception level 0 and exception level 1, exception level 2 corresponds to the privilege level 2. So as I stated in the previous lecture, exception level is not the level of exception. They match the concept of privilege level. The software at exception level 2 can access to system resources just like system register that is affixed with EL1 of the guest OS. This kind of operation can be then allowed in order to monitor or inspect the workload of multiple guest OS. The hypervisor used to run at exception level 2 to monitor the workload of multiple guest OS. That is the feature of hypervisor. So if you're involved in any project, that project is about automotive sector, automotive project, you surely notice that system architecture is based on virtualization. In this case, it is extremely important to understand how this virtualization can be organized in your system. Now that we got to know about the concept of exception level 2, in the next lecture we will explore the more higher the privilege level, that is exception level 3.